again on the video notes. Yeah, the video notes. Oh, the video notes. Once again, you're here on the video notes. Oh, the video notes. Yeah, the video notes. I'm here, you're there. You can listen to me almost anywhere. Here we go again on the video notes. Yeah, the video notes. Say the video notes. Forms of energy on the video notes. On the video notes. On the video notes. Hey, welcome everybody to this week's video notes from Mr. Flugum's class. We're talking about forms of energy today, and let's get started. By the way, these notes will go on page 25 in your science notebook. Thank you. Alright, so getting started here, just a little review of stuff we talked about last week, right? Energy, right, can cause change, has many different forms to it. And then the really important thing there is that law of conservation of energy. And that's what we're really going to focus on today, that part where it says it can only change forms. So what does that mean? And how does that apply when energy does change? Alright, so here we have a list of 5 different common forms of energy. These are forms of energy that we see all around us, all the time. And we use them. We enjoy them sometimes. Sometimes we don't like them. Sometimes we make them happen on purpose. Sometimes we don't. All right, but these are all forms of energy. So one of the things that you need to be familiar with is different forms of energy, and we're going to talk about how these forms of energy change. All right, so you may be thinking, well, Mr. Flugum, that wasn't all the forms of energy we talked about last week. Well, that's right, but I wanted to keep it separate. Potential energy. Potential energy, remember, is stored energy, right? It's not happening or not being released right at the time. And the book kind of tells us that stored energy is energy that's stored due to location, shape, or the arrangement of atoms. All right? So there's the one we talked about last week, right? GPE, energy stored in object above Earth's surface. And then there's 2 other kinds of potential energy. All right? It's energy stored in chemical bonds, right? That's chemical potential energy. Chemical potential energy we use all the time. We use it in our bodies. The food that we eat is chemical potential energy, right? Our body breaks apart those chemical bonds and uses the energy stored in them to keep us going. Okay, we also use it in cars. Candles would be another example of using energy stored in bonds to do something, to make light, to make heat, to make things move. Alright, so the last kind of potential energy is the elastic potential energy, right? So this is energy stored in objects that can stretch or compress. So you can see the tennis ball there, right? That's compressed. So when a tennis ball bounces, it deforms, but then it wants to spring back into shape, right? And that's what helps it bounce, is that springiness. So it stores energy when it hits the ground. Okay? You also store energy by stretching things like that rubber band. And then we also have the springs there, right? Springs can either compress or be stretched in order to store energy. Now we need to look at how does energy get changed. And we've looked at this some in class and talked about it, but I want to think about this, right? Energy changes forms easily. So here we have a ball rolling on a track, right? And when it starts at the top there, it has mostly GPE and barely any kinetic energy, right? Now as it rolls down the hill, that GPE gets changed into kinetic energy. Okay, so when it's at the bottom of the hill, it's at its like maximum of kinetic energy, right? Okay, then as it rolls back up, kinetic decreases, right? Because it's going to slow down, and the GPE increases, and so on as the ball goes up and down. Okay, that teeter-totter effect with GPE and kinetic energy is going to happen. Okay, here's one other idea, and we're going to discuss this one in class, so I'm going to leave a little bit of it to you. But you've got this wind turbine here, and it's powering a lamp. And boy, I wish that picture of the lamp had turned out a little better, but that's the way it goes. So what forms of energy are being used and transformed, right? And what do we end up with? What do we start with? And then can we ever use this energy again? That's something to think about. Now I'll start you off. At the beginning, we have moving air, right? what kind of energy does moving air have? Okay. If you answered kinetic energy, well, you're right. So that's what we start with. Okay. Now, I want you to write down on your paper in your notes what kind of transformations happen with that kinetic energy. What does it get changed into? And then changed into again. All right, to wrap it all up, what do you need to know? You need to be able to tell me different kinds of energy, right? You need to be able to name and describe potential forms of energy, right? That's stored energy. And then last but not least, you need to describe how energy is transformed in a system, right? So that means, when we have the ball rolling on the track or the roller coaster on its track or any other situation where energy is being used. Thanks for tuning in, folks, and I hope you have a great day. I'll see you in class on Wednesday or Thursday.